Now we're going to train our model the PyTorch way. So we'll create our dataset object, and nothing much has changed here. And our linear regression module stayed the same. We can create a criterion function, i.e. our total loss or cost function, but PyTorch has its own built-in functions, so we'll use msc.loss, and we'll represent it with this blue square. We'll create a train loader object, and we'll represent that with that pink square over here. So we'll create our object, represent the model. Now the biggest difference is we'll have this optimizer object, and SGD is short for stochastic gradient descent, and the parameter LR is the learning rate. We'll use the method model parameters, and that'll provide a connection between our model and our optimizer. So we'll run through our training loop. We'll choose 100 epochs, and we'll take the data from our training loader. Now nothing much has changed in these two lines of code. Now, similar to how we cleared the gradients for the variables, we'll clear the gradients for the optimizer, and that's just through how PyTorch calculates the gradients. So as before, we'll call loss.backwards, and then instead of differentiating the individual variables, we'll call the method step on the optimizer objects. And what this does is it performs these two lines of code. Now for this simple model, this doesn't seem like a lot, but as our models get more complicated, this will become very difficult. So I find this a little confusing, so let's clarify with this diagram. So we have our train loader object, which is represented by the pink square, and we use a train loader object, and it'll feed the value of x into the model to perform a prediction. Then we'll use the actual value, y, and the predicted value, y hat, to calculate the loss. Now, we call loss.backwards will differentiate the loss. I calculate the derivatives, and the optimizer step will perform an update on the model parameters accordingly. If you remember, we use the method models.parameters in the optimizer constructor. So it's helpful to define your own function to train. We just input all the parameters such as model, criterion function, i.e. total loss or total cost function, our train loader object, our optimizer, and the number of epochs. But this will help us simplify our code and make our code easier to read. And that's it.